Second question, a mixture containing 28 grams of argon and 14 grams of HBr gases are placed in 8-liter container at 30 degrees Celsius. Again, the question involves two gas. So I usually made a story for my question like this. So we've got argon of 28 grams and 14 grams of HBr. So next, we're gonna mix these two gas in 8-liter container at temperature of 30 degrees Celsius. The question asks to determine the partial pressure of each gases and the total pressure inside the container. This is a direct question. Partial pressure. So look back at your note. PA equal to XA times PT. So PA equal to XA times PT. Alright, so first thing first, check your info. Pressure A. We want to find it. Okay, for example, let's change this A to AR. So partial pressure of AR, do we have it? No. The mole of AR, can we find it? Yes. Because we've got the mass. And the total pressure, can we find it? That would be hard for us. So no. So it will be hard for us to find our partial pressure using Dalton's law formula. But class, please highlight that. The question said, assume the gases are ideal. Okay, this is our main point because we need to understand that we've got to use the formula of PV equal to nRT. Make a note, if we want to use PV equal to nRT in Dalton's law formula, in Dalton's law equation, then your volume must be, so we've got the total volume already, which is 8 liters. Okay, remember that we've got both of the gases in a container. Okay, so check. Okay, we want to find the partial pressure of each gas. So rearrange your equation. PAR would be mole of AR. R would be the gas constant. T would be the temperature over volume. Okay, remember that volume must be total volume. So check again. Pressure, we want to find it. Mole, yes, we can find it. R is given, T, we've got it, and VT, we've got it already. So, yes, we got to use this PV equal to nRT when for this kind of Dalton's law question. Okay, so PAR. Okay, first we need to find the mole. So pressure AR. So your mole for AR would be 28 divided by 39.95. So your mole of AR would be 0.70. For HBr, 14 divided by 1 plus bromine, 79.90, 0.173 mole. So substitute your moles into your ideal gas equation. So mole AR 0.70 times R 0.08206 times temperature. Okay, remember class, the temperature must be converted to Kelvin. Okay, when we are using the gas equation, so that would be 303 Kelvin divided by volume total 8. So that would be 2.1783 atm. So second is to find the partial pressure for HBr. The mole is 0.173 times 0.08206 times 303 divided by 8. So the answer is 0.538 atm. Okay, remember class, the unit for pressure when we are using the ideal gas equation must be in atm. Okay, so if you are just answer the unit as torr, for example, then your final answer would be wrong. So next is to find the total pressure. Okay, so it's very simple. Just add up your gases 2.1783 plus 0.538 to be 2.761 atm. Again, I'm just gonna highlight off this equation. You need to make a note when the question stated the gases are ideal. You need to consider the probability of using ideal gas equation to find your pressure or the total pressure.